Hello, ladies and gentlemen. Welcome back. Let's look at Unit 7.2. We're going to solve systems of equations by substitution. The steps are listed right here. You might want to pause and write them down if you need to. Step 1, we're going to solve one of the equations for one of its variables. Step 2, we're going to substitute the expression from step 1 into the other equation and solve for the other variable. Step 3, substitute the value from step 2 into the revised equation from step 1 and solve. Okay, now that might sound complicated, but really it's not too bad. Here we go, ladies and gentlemen. So here's our first problem. 2x plus 5y equals negative 5, x plus 3y equals 3. Remember, our ultimate goal here, ladies and gentlemen, is to see where they cross each other, except we're not going to use the calculator here. We're going to use algebra. So step 1, we want to look at both equations and pick out the one where we can solve for one of the variables very quickly. Okay, well, I want you to notice, ladies and gentlemen, that this x, okay, it doesn't have anything else in front of it. It's just x. So we want to pick that one because it only takes one step to get the x by itself. And to do that, we're going to subtract 3y from both sides. Okay, so now I'm going to rewrite this as x equals, now I'm going to put the negative 3y first and then the plus 3 behind it. That's the same thing. Okay, so step 1 is done, ladies and gentlemen. I have solved one of the equations for one of its variables, and I want to pick the one where it only takes one step to do that. Step 2, it says, okay, substitute the expression from step 1 into the other equation. Okay, so what we're going to do, ladies and gentlemen, is we're going to go ahead and take the negative 3y plus 3, and we're going to plug that into the other equation for x, okay, because that's what x equals. All right, here we go, ladies and gentlemen. Let's go ahead and rewrite that now. So what I have is I have 2. I'm going to replace the x with the negative 3y plus 3. Okay, but first I'm going to write the rest of that out. Okay, so I'm going to throw that x out the window, and I'm going to go ahead and put the negative 3y plus 3 in that spot. Okay, well, now it says solve for the other variable. That means we need to solve for y, folks, because that's all that's left, right? So we have to do a bit of algebra here. We have to do the distributive property. Okay, when we do the distributive property, we now have 6y plus 6. Okay, multiply to both of those terms. Plus 5y equals negative 5. All right, well, now we combine like terms. Okay, we've been solving equations for years now. Combine like terms, so the y's, that would be negative y plus 6 equals negative 5, if I'm not mistaken. And then now we got 2 more things to do here. We got to subtract 6. So I have negative y equals negative 11. Okay, well, we can't have a negative 11. So if you remember, folks, divide by negative 1. And so we end up with y equals positive 11. Okay, but that's only half the answer. Oh my goodness, are you kidding me? Nope. You've done this before, folks. You did this in intermediate algebra. All right, so now what does it say? So step 2 is done. Step 3. Substitute the value from step 2 into the revised equation from step 1. Okay, well, ladies and gentlemen, that would be what I've got circled in green. So now what we're going to do is we're going to take this 11 and we're going to plug it in to the y in the revised equation. All right, so I'm sorry, this is so sloppy. Normally, I'm much more neat in how I set things up. So I'm going to take x equals negative 3. I'm going to replace the y with 11 plus 3. Okay, well, that means x equals negative 33 plus 3, which is negative 30. Okay, x equals negative 30. All right, well, my final answer here, folks, we're going to write this as an ordered pair. Where do these two cross each other? Okay, they cross each other at negative 30, comma 11. Okay, hopefully I didn't mess up on any of my algebra there. I don't think I did, but that's what we get for that one. Okay, that was a lot. Rewind it and watch it if you need to, but I'm going to go ahead. We're going to do another one. Here we go. Okay, you ready? 3x plus y equals negative 13. Negative x minus 2y equals negative 4. All right, folks. So I look at both of those, and I'm going to pick this equation, and I'm going to solve for y because it only takes one step. To get y by itself in this problem, I'm going to subtract the 3x. Okay, so now I have y equals negative 3x minus 13. Okay, so that's step number 1. Now I'm going to do step number 2. I'm going to take the negative 3x minus 13, and I'm going to go to the other equation right there, and I'm going to replace that y with negative 3x minus 13. All right, so I've got negative x minus 2. I'm going to replace the y. Okay, and I'll color code it this time. We've got negative 3x minus 13. So I put that in the other equation for y. Now I'm going to do my algebra. I'm going to distribute. So I've got negative x. This becomes plus 6x because I multiplied negative 2 times negative 3. And this becomes plus 26 equals negative 4. Okay, I'm going to now combine like terms, the negative x and 6x, that's 5x plus 26 equals negative 4. Okay, now I'm still on step 2. I'm solving, I want to find what does x equal. Okay, so again, I'm going to continue with my algebra here, ladies and gentlemen. So I'm going to go minus the 26. So now I've got 5x equals negative 30. I'm going to divide by 5. And I end up with x equals negative 6. Okay, that's half of my answer. Okay, so if I make my ordered pair, that's my x value. Okay, so that's step 2. All of that was step 2. Step 3, we're going to take that. I'm going to draw my little arrow here. I'm going to take that value and I'm going to go and plug it into this x because I want to know what y is. So I've got y equals negative 3. I'm going to replace the x with the negative 6. So I get positive 18 minus 13, and that looks like that's going to be a 5. So my answer to this problem is negative 6, 5 as an ordered pair. Okay, let me pull this, do this so you can see the whole thing. Okay, we found the equation. We got one variable by itself. Then we plug that into the other equation for that variable and then solve for the other variable. Then we take that answer and plug it into the variable we solved for and then find the second variable. Wowzers, folks. Okay, pause and rewind if you need to. All right, let's look, ladies and gentlemen, at this one. This one looks a little bit different. You notice that it says y equals and y equals. Well, if they both are already solved for y, guess what? Then we set them equal to each other. So we're going to take the negative 3x plus 2 and we're going to set it equal to 2x minus 3. Think about it. If y equals the top one and y equals the bottom one, logic dictates that the top one then equals the bottom one, right? Okay. Now, I like to always solve and have my variable be positive. So what I'm going to do that, ladies and gentlemen, is I'm going to add 3x to both sides so I can keep that positive. So now I have 2 equals 5x minus 3. Okay, again, our goal is to get x by itself. So I'm going to go ahead and subtract 3 now. No, add 3. Add 3. So now I've got 5 equals 5x. And then divide by 5, and I find out x equals 1. Okay, I should write that down here. X equals 1. Now, here, it doesn't matter which equation we pick, folks. Okay, I now need to find my y value. So I'm going to go ahead and plug that 1. I'll plug it into this one. All right, so I'm going to take y equals 2. And I'm going to replace the x with a 1. And so now what I have, ladies and gentlemen, is I have y equals 2 times 1 is 2 minus 3, which is negative 1. So my y value is negative 1. So as an ordered pair, folks, the answer is 1, negative 1. That's where they cross each other. Now, what really is cool is now we can actually look at some word problems. It's about time we get to real life applications here. Walter Heater, get it, heater? Okay, Walter Heater must make a decision about spending $100 to fix his old water heater. All right, it is an electric unit, and he estimates that it costs him $125 a year to provide his home with hot water. His other option is to buy a new gas water heater for $350, including installation. Because the new unit will be more efficient, he will spend about $75 a year to provide his home with hot water. How long will it take until the new unit pays for itself? All right, well, let's see here, ladies and gentlemen. He's going to spend $100. He has to decide to spend $100 to fix his old water heater. And it costs $125 a year to provide his home with hot water. His other option is to buy a new gas water heater for $350, and then it's going to be $75 a year to provide the home with hot water. How long will it take until the new unit pays for itself? All right, folks, let's see. Before I go any further with this, I am going to go ahead and define my variables, folks. I'm going to use x and y. All right, so what I'm going to do is I'm going to let x equal, okay, number of years. All right, and I'm going to let y equal the total amount. Okay, so the first situation, ladies and gentlemen, is $100 to fix the old one, and then it's going to be $25 a year to provide his home with hot water. If you think back to our first lesson, you should be able to write an equation for that. So we're going to go y equals 125x plus the $100 to fix it. Okay, and then the other one, ladies and gentlemen, is he's going to buy a new water heater. Water heaters are a lot more expensive than that, folks. They're in the thousands of dollars. Okay, unless you get a really cheap one. Okay, $350 to buy a new one, and then he's going to spend $75 a year. So that's going to be y equals 75x plus 350. So this problem looks just like that last one. What we can do is we can set them equal to each other because they both equal y, right? Because we want to know, ladies and gentlemen, how long will it take until the new unit pays for itself? Okay, well, first we're going to go ahead and set these equal to each other. So 125x plus 100. So we're going to figure out, well, when will they cost the same amount? Okay, when will they cost the same amount? And then we'll be able to answer that question. All right, so let's see. I'm going to go ahead and subtract 75x. And that would give me, let's see, that would give me 50x plus 100 equals 350. Now I'm going to go ahead and subtract the 100. All right, and then I get 50x equals 250. And let's see, divide by 50. And I find out that, okay, x, again, this is how many years it will take, and then that'll be the same amount. Well, let's see, 50 goes into 250. Let's see, 1, 2, 3, 4, 5 times. Yep, 5 times. So in 5 years, it'll be the same amount, okay? So if you fix it or you get a new one, okay, that's when they end up being the same amount, is 5 years. So when are you going to start saving money? How long will it take until the new unit pays for itself? Well, I guess that is the answer. 5 years. Okay, 5 years is the answer. Okay, when are you going to start saving money? Okay, well, you're going to start saving money after the 5th year. Okay, so it'll cost you less to fix it. It'll cost you less to fix it for the 1st, 2nd, 3rd, 4th year. The 5th year, it would then be the same amount, okay? But then after the 5th year, you're going to start spending less. So in the end, it is worth getting the new one. It's just at first there's going to be more money spent up front, but in the long run, after 5 years, you're going to start saving money. Okay, so again, we set up our equations, we set them equal to each other, and we found that x equals 5 years. It didn't ask us how much money was spent. It just asks how long will it take until the new unit pays for itself. 5 years. All right, folks, that was it. We'll do more of this